All right, so vectors are linearly independent if, well, there's no dependence on each other. So linearly independent means that if we have some sort of vector equation, or some sort of linear combination of vectors, sorry, and we set it equal to 0, these vectors are linearly independent if the only solution is the trivial one, where all of our coefficients are equal to 0. So if the only solution is k1 equals k2 equals kn is 0, then our vectors are linearly independent. So for example, if any of these vectors were multiples of each other, then they would not be independent. It's the same vector, just as a different multiple. So linearly independent means that the homogeneous set of equations only has one solution, and that's the trivial one. We think about these when we think about finding a basis for a vector space. So if V is any vector space, so we've got V as a vector space, and S is a subspace of V. Then we say that S is a basis if two things happen. S is linearly independent, and S spans V. So we need the two of these things to form our basis, because if we think about our basis as describing a coordinate system for vector space V, then the linearly independent part guarantees that there's no interrelationship between our vectors. So linearly independent implies no, that's an N, interrelationship between vectors. And then the span guarantees that we have enough vectors to cover all the coordinates in V. Yeah, so we need both of these things. The first one basically means that we have no redundancies, and the span is ensuring that we're covering all of V. Dimension is going to be, as it sounds, it's going to be our n value. So dimension of S is equal to n. It's the number of vectors required in order to span. And we'll look at some examples in the next videos.